Good morning, professors, and welcome to an exciting new experiment conducted with the Wacebo ScienceBus. In today's engaging experience, we will explore how to effectively use a digital multimeter to accurately measure the equivalent resistance of a circuit with resistors arranged in parallel or mixed configurations. For this purpose, we will require the electricity kit. The experience is appropriate for high school students. Utilizing the circuit board, we proceed to meticulously insert the various boxes in order to establish a parallel resistor configuration. The circuit that has been constructed in this manner contains two resistors arranged in a parallel configuration, one with a resistance of 100 ohms and the other with a resistance of 220 ohms. The objective is to accurately measure the equivalent resistance by utilizing the multimeter. Now, let us proceed to carefully insert one end of the red-colored cable into the aperture of the two-hole box and the other end into the volt-ohm port of the multimeter device. Let us proceed by taking the black-colored cable and carefully inserting one end into the aperture of the two-hole box, while the other end is inserted into the COM port of the multimeter device. Subsequently, adjust the selector to the OHM setting and ensure that the appropriate range is selected. In this particular scenario, it is appropriate to adjust the setting to 200 OHM. Now let us power on the multimeter and carefully observe the equivalent resistance value that appears on the display screen. Let us compare this particular value with the precise one. When two or more resistors are connected in a parallel configuration, the potential difference across them remains consistent, while the electrical current is distributed among the various branches. The equivalent resistance of a circuit that incorporates N resistors in a parallel arrangement is ascertained by employing the subsequent formula. Consequently, by performing the calculation, we obtain an equivalent resistance value of exactly 68.75 ohms. Let's proceed by altering the circuit configuration, so we switch off the multimeter and substitute the 100 ohm resistor with a 470 ohm resistor. Let's activate the multimeter and carefully observe the equivalent resistance value that appears on the display screen. Let's then proceed to compare this particular value with the one that was obtained through the application of the formula. Let's proceed to establish a more complex configuration by incorporating resistors in both series and parallel arrangements. Let's activate the multimeter and carefully observe the equivalent resistance value that is displayed on the screen. Let's then compare the measured value with the actual one. To ascertain the equivalent resistance of the entire electrical circuit in this specific scenario, we must first calculate the equivalent resistance of the loop that encompasses the resistors connected in a series configuration. These two resistors function as a single resistor, which will subsequently be positioned in parallel with the 470 ohm resistor. Let's proceed to repeat the experiment by establishing an even more intricate configuration. By employing the multimeter, we accurately measure the equivalent resistance, carefully comparing the value shown on the screen with the actual value obtained from the formula. In order to compute the equivalent resistance of the entire electrical circuit, we must initially determine the equivalent resistance of the resistors connected in series within the initial loop, specifically the 220 ohm and 100 ohm resistors. The equivalent resistance of this particular loop must be strategically positioned in parallel with the 470 ohm resistor, and the resulting parallel resistance should then be methodically arranged in series with the 220 ohm resistor. The experiment thus allowed us to measure the equivalent resistance of a circuit with multiple resistors in parallel or more complex configurations, where we have resistors in series and parallel using a multimeter. Professors, thank you. We will see each other at the next experiment. Goodbye.